Hi guys, in the last video we ended the standard normal with me saying, well, really no point in using it. And most of the time there isn't. But the only time I personally ever use it to solve a problem, because now the calculators are so good, is when I'm asked to find the mean or the standard deviation. Let's have a look at some questions. So here's a good one. So we have a distribution of x. It's normally distributed, but we don't have the mean, but we do have the standard deviation. Now, we're also told a little bit more information here, so let's just draw this out. We don't know the mean, but we know values less than 16 have a probability of 0.9. So if that's 16, what we do know is this is a probability of 0.9. This is for the x distribution. So I can't use my calculator at this point because of this problem here. So what we're going to do is for my standardized normal, and that's really useful because now I know the mean is 0. And what I can do is work out how many standard deviations above the mean 16 is. We can't use this formula here because I don't have the mean. So I'm trying to find that, and I don't have that, so it's not going to work. So let's pick up our calculators and go menu 7 and inverse normal, because anytime you've got an area, you just use the inverse normal. So we're going to put that as 0.9, press equals, standard deviation is 1 and the mean is 0 because we're now looking at the standard normal. And I know that 16 is 1.28 standard deviations above the mean. So I am going to use this formula, so I wish I didn't cross it out now, but 1.28 is going to be equal to the score, the observed value, 16, minus the mean, over the standard deviation, which is 3. And now we just simply rearrange that. So I'm going to do that on my calculator quickly. So menu answer times 3, 16, take away that. The mean is 12.1553 to 4 decimal places. If in doubt, write everything to 4 dp. Okay, let's have a look at another one. So in this one, we're asked to find the standard deviation. So very similar, let's just draw our distributions. So this is x, that's 12. We don't know the standard deviation. We do know this though, all values greater than 15 have a probability of 0.15. Okay, so that's pretty rubbish because of that gap, but we're going to go with it. Always label your axes, don't ever be lazy here. So we need to work out how many standard deviations above the mean is 15. Now, I'm going to shade in the other bit because when we use our calculators, we're always interested in cumulative. So this is 0.5, this is 0.15. So calculators ready, menu 7, inverse normal, area is 0.85, and this tells me it's 1.036 standard deviations above the mean. So our z-score is 1.036. That's going to equal our observed score, take away the mean, all over our standard deviation. You pull the switcheroo here. So menu 1, 3 divided by the answer, and it's 2.8945 to 40. Okay, I think I've got one more. Yeah, best sport in the world, hockey. Look at that grip, it's our school grip. Now, so hockey grips are made with a mean of mu and standard deviation. Wow, we don't know either. So let's start off by defining a random variable. So let x be the random variable length of grip. And x is distributed normally because they didn't tell you that. Well, they will tell you that. It's just I've made a mistake there. So they're going to tell you that it's distributed normally. It's continuous anyway, so You can't use binomial, for example. And we don't know that, and we don't know that. Great. But what do we know? So given that 10% have less than 100, so given that 10% have a length less than 130, so let's draw our distribution x. So we don't know that, but we know 10% are less than 130. So right, I put 130 here. That must be 0.1. We also know 5% have a length greater than 150. So if I put 150 here, you know that is 0.05. So whenever you have unknowns in these parameters, draw your standardized normal distribution. So I just snuck on that squared there. I missed it. So we know that is 0. And what we need to work out is how many standard deviations this is below the mean. So we can do that using the inverse normal. And for this one, I'm going to be typing in 0.95. So let's go. All right, so area 0.1. Oh, 0.11. So that is minus 1.28. I'm just going to shorten it to 2 dp, but I'd normally use 4. Just makes it a bit quicker. And the next one is 0.95. So that's 1.64. So we say now, well, we know minus 1.28 is equal to 130, take away the mean, divided by the standard deviation. We also know 1.64 is 150, take away the mean, divided by the standard deviation. So therefore, I can write minus 1.28 lots of the standard deviation is equal to 130 minus the mean, and 1.64 standard deviations is 150 minus the mean. Simultaneous equations, let's eliminate these. So let's subtract them. Let me just use my calculator for that, otherwise I will go horribly wrong. 1.64 add 1.28 minus minus, don't get caught out by that. So that's 2.92 standard deviations is equal to 20. So 20 divided by my answer is 6.849. I'm going to pop that into this one. So I'm going to times that by 1.64 and take that away from 150. So the mean is 138.77. Right, now, wow, this question keeps on going. So I'm just going to, come on, yeah, we can still see that. So 20 grips are chosen at random. Find the probability that at least 4 of them, so this is now a binomial problem. How exciting. So let's first of all need a probability for the binomial. So we now know this is 138.77. And we're looking for above 145. So what is the probability of in this region here? So let's work it out. So menu 7. This time I'm going to use, because I don't know this, so I'm not going to use the inverse. I'm just going to use the normal CD. My lower, I'm going to put just 0. That's the lowest length it could ever be. The upper length, I'm going to put 145. You could put 145 as the lowest and like, say, 1,000 up here. Standard deviation would have been really useful if I'd stored these, but I didn't. So here we go, 6.8493, and the mean is 138.77. And up to this point, which is what I'm working at, up to this point is 0.818. So I'm just going to take that away from 1, and this is 0.1815. Right, so let's well, this still, no, it's not. So we need to put a new variable. So let y be random variable. So this is now number of grips greater than 145 centimeters. So y is distributed binomially with a sample size of 20 and a probability of 0.1815. The question is probability at least 4. So greater than or equal to 4. That means 4 or more. So that's the same as 1 minus, sorry, this is a y, my apologies, is less than or equal to 3. Now, I've gone through this pretty quick, but if you're doing the normal distribution, which is year 2, I'm pretty sure you understand the binomial. Well, I hope so anyway. So, menu 7, binomial CD, cumulative distribution, variable, and we're going to put 3 in for our observed value. Our sample size n is 20, and our probability is 0.1815. So 1 minus 0.4955. Just finish this off. 1 minus that, and we get 0.5045. Wow, what a question. You gotta love that. That's it, guys. Nothing more. Got lots of work to do. So best of luck, and chat to me on Teams if you get stuck.